Hi, in this video, I'm going to talk about question number 9 of homework 9 of probability and stochastic processes course. So let's dive into the question. In this question, we have a sequence of independent random variables, x1, x2, till xn, and using these independent random variables, the question is defining y that yn is equal to sum of x1, x2 till xn. And the question is, prove or disprove that yn is a Markov chain. Let's go to my answer. Uh, uh, in the general speaking, if we want to prove that some random variable is Markov chain, we should show that the probability of, for example, in this question, y of n plus 1 given yn till y1 is equal to the probability of y of n plus 1 given yn. So if we have a Markov chain, we don't care about all the previous states. We only care about the last and most recent previous state. So in this question, we're going to prove this. So as I told you, we will first write the probability of yn plus 1 equal to yn plus 1 given all the previous states. And we know that the y of n plus 1 is equal to yn plus x of n plus 1. So we will substitute the y of n plus 1 with x n plus 1 plus yn. And we can substitute the value of a random variable yn with its value, which is y small letter n. And then we can move all these terms into the right side. So the probability of x n plus 1 equal to yn plus 1 minus yn given all the previous states. And as we know that xi's are independent, we know that the probability of xn plus 1 is only dependent on xn, so we can remove all the other parts, and then we will do the reverse process to omit xn plus 1 and go back to yn, so that we can declare something about yn. So again, we will write the probability of xn plus 1 plus the random variable yn is equal to yn plus 1, and we can remove xn plus 1 and substitute it with yn plus 1 equal to yn plus 1 given yn equal to yn. So using some mathematics, I could prove that the probability of yn plus 1 equals to yn plus 1 given all the previous states is equal to the probability of yn plus 1 equals to yn plus 1 given the only most recent previous state. So the proof is complete. Thanks for listening to me.